Hi Year 10, welcome to your Maths Foundation LP2 overview. Remember, the purpose of these videos is to give you an insight so you can recall and recap all of the skills that you've learned over the course of Year 10. Today I'll be focusing on everything that you've learned in LP2. I'll be identifying some of those knowledge organisers and I'll be highlighting some of the key concepts and key skills that you need to know. So let's start today by looking at the first knowledge organiser. So I've identified 6 topics on this one. We've got ratio, simple interest, factorising, adding mixed numbers, surface area, and perimeter of compound shapes. So what I'll do is break those down into each individual topic, go over some of the core concepts and key vocabulary, and then we'll recap on the skills that you need to know within each of those topics. So let's start first of all by looking at ratio. Now, last half term in LP1, we looked at being able to secure sharing ratio and simplifying ratio. So now we're looking at being able to apply ratio in different ways, and developing that with the use of recipes is how we focused on this kind of core concept within ratio. So we'll be using proportion here. You'll need to understand how to scale down or scale up different ingredients to find out the correct amounts for each person. This may be quite a straightforward, simple question, or you may have to think about multipliers, divisors, and using that kind of information as well. So this example here, we've got a list of ingredients that make small cakes. So we've got 400 grams of flour, 200 grams of butter, 200 grams of sugar, and 2 eggs. And we're told that this makes 15 cakes. Rosie has these ingredients. So she's got this amount of ingredients for each part of this recipe. And we're asking, what is the greatest number of cakes that she can use? So you will look at some of this information and you will see how many of these ingredients can be divided into that recipe, and this should give us the answer of how many cakes she can find in total. Now, something that we need to be careful with here, when we're working with recipes, we'll be given weights either in grams or kilograms. You need to know that there are 1,000 grams in 1 kilogram. At some point, you will be asked to convert there, so that's really important. The next topic is looking at simple interest. Now, this is linked to kind of bank accounts, percentages, and being able to add percentages as an increase on top of an original amount. So interest is something that is added on when we're thinking about banks and simple interest. And the words per annum is another way of saying each year. So Sally deposits £600 into an account with an interest of 5% per annum. So she gets 5% of £600 per year on top of her investment as interest. So we can use that information to work out how much interest Sally would get after 3 years, and then how much that would then add on to the total amount that she's got. So calculate the interest that she receives after 1 year. So we would find 5% of 600, and we can use our multiplier there. And then the second part of the question asks about how she would add it on for 3 years. So we would multiply that by 3 and then add that on to her original deposit. So simple interest is a good way of working out your percentage increases on top of an amount, and it's specifically linked to real life maths when you're working with bank accounts. So the first 2 things that we need to look at when we're working with ratio, we need to apply ratio to recipes. And when we're working with simple interest, we need to be able to calculate simple interest without a calculator. Then we need to be able to calculate simple interest with a calculator, because you could get this type of question on either paper. And then we need to be able to compare interest rates. So if someone has deposited a larger amount with a smaller interest rate, how would that compare to someone who's deposited a smaller amount with a larger interest rate? And you may be asked to compare those and give your reasons. The next two topics that I've identified are factorising and adding mixed numbers. So when we factorise an expression, so here's an example of an expression, and I want to factorise it. What I mean by factorising is by putting the expression back into brackets by taking out the highest common factor. So what we need to do is look at what factors the 2 and the 6 have in common here. What is the highest common factor of both of those numbers? Once I have the highest common factor, I remove that from my expression, and this goes on the outside, and we look at any other factors that may be in common here. So you can see that they also have an X that's in common. So I'm going to take out the highest common factor of 2 and also this X, and the rest of this expression making up this will be inside that bracket, and I would find that by kind of dividing by your highest common factor in each of those parts of the expression. The coefficient, so a key vocabulary term there, is the number that's in front of this unknown value here. So the 2 here and the 2 here are my coefficients because they're in front of the unknown value of X. So there are lots of different ways to factorise. This one in particular focuses on factorising back into a single bracket. So if you think about inverse operations, factorising is the opposite of expanding a bracket. So instead of expanding a bracket, we would factorise it as well. The next one, looking at adding mixed numbers. So just 2 key vocabulary terms here. Improper fraction, we looked at this back in LP1, being able to convert between an improper fraction and a mixed number. So that was the term convert there. And the easiest way to add your mixed numbers, if they do not have that lowest common multiple in common, then we would want to be converting these into improper fractions here and here, and then finding the lowest common multiple and scaling those up. You can then convert back at the end. So if you have your answer as an improper fraction, you can then convert that back into a mixed number. So the skills that we need for these 2 topics: to factorise, you need to be able to factorise an expression, and to add mixed numbers, you need to be able to add mixed numbers with the same denominator and also add mixed numbers with different denominators. The final 2 topics on this first knowledge organiser are surface area and perimeter of compound shapes. So when I think about surface area, we're looking at the faces of the shape. So this shape in particular is a cuboid. We can see that the lengths are all different, so it's not a cube. When we look at the surface area, we are concentrating on the face of each of the shapes. So we can see here the blue would be the top and also the bottom. The purple would be the front and the back, and the green is the left and the right. The total surface area is found by finding the area of each face, which we would do by multiplying, and then we would add all of the faces together. And this will give us our total surface area, and it's always in units squared. So this example, we can see the blue, 8 times 5 is 40, and we have 2 of those, the top and the bottom. So 2 lots of 40 centimetres squared. The purple is the front and the back. We can see that this is 7 by 5, which is 35, and we have 2 of those. And then finally, the left and the right, we have 7 by 8, which is 56, and we have 2 of those. So we would then add all of those individual ones up together. 80 plus 70 plus 112, 262 centimetres squared. So that would be our total surface area. For the perimeter of compound shapes, when I think about the word compound, okay, this is a shape that's made up of maybe 2 or more shapes. So you can see here, this shape is 2 rectangles kind of pushed together. So this would make a compound shape. And the perimeter of a shape is always noted as the outside lengths of the shape here. And we can see that we've got some missing sides to identify as well. So to find the total perimeter of a compound shape, you would need to add up all of the sides and include any of those missing lengths that we have here as well. To do that, we would look at any lengths that we already have in the question, and we would be subtracting to find out those missing lengths. So here, for example, this whole length is 10. If I go to the top, this little length is 4, meaning that this part here must be 6. That's the bit that's left over. And then this whole length here, I would find by looking at this length, which is 3, and then adding on this length, which is 5. That will give me 8. Once I have all of those missing values, I can add all of them together, and my units for this is in centimetres for this question. So you can see there the length is in centimetres. So for these 2 topics, the skills that you need to focus on are being able to find the surface area of cubes and of cuboids, and here being able to find the perimeter of a compound shape when you are given all of the lengths, and also find the compound shape area of a shape when you don't have all the lengths and you might have some of those missing. So just to summarise that first knowledge organiser for LP1, you need to look at, can you do the following skills? Can you apply a ratio into a recipe? Can you work with simple interest with and without a calculator? Can you factorise an expression? Can you add mixed numbers with the same denominator or with a different denominator? Can you find the surface area of cubes, cuboids? And if you're confident with that, can you solve some surface area problems as well? And finally, working with perimeter, can you find the perimeter of a compound shape when all of the sides are given? And can you find the perimeter of a compound shape when there are missing lengths? What I'd like you to do is go on to Corbett Maths and have a little look at some of these topics and try to do those by yourself. If you can answer those questions correctly, then you know that you've achieved that objective and you can do that skill. If you can't do it, then that's okay. That just means we've identified a gap in your knowledge, and our job is to make sure that we fill that gap and that you're secure with that skill before your exam. So moving on to the next knowledge organiser within LP2. The next 6 topics that I've identified for you are linear inequalities, plotting straight line graphs, dividing mixed numbers, exterior polygon angles, ordering fractions, and exchange rates with ratio. So again, I'll just go over each of those individually, highlight some key terminology, and then we'll go through the skills that you need to master within each of those core concepts. So firstly, linear inequalities. In LP1, we looked at being able to note an inequality and plot an inequality on a number line and identify any of the numbers that satisfy that inequality. This particular topic now moves on to being able to solve a linear inequality. So similar to an equation, The notation here is really important because we're using those symbols of greater than, less than, greater than or equal to, or less than or equal to. And when we've solved that inequality, it's very important that we continue to use the same symbol throughout that whole equation. These are all linear inequalities, which means they have an unknown variable there, for example, of m. They're not kind of a square or cubic equation, they are a linear equation. So we would solve a linear inequality exactly the same way as we would solve an equation. So we would use our balancing method and we would apply the inverse operation to find that missing value. The second topic, plotting straight line graphs. You need to be familiar with how to draw an axis using your X and your Y. Also being familiar on how you plot your coordinates of X and Y. Your X coordinate always goes first, and then your Y coordinate goes after that. So this will tell us left or right for X, and this will tell us up or down for Y. So you need to be able to plot a 4-quadrant grid accurately, and then you need to be able to plot a straight line graph as well, using a table of values when they're already given to you. The next two topics, dividing mixed numbers and exterior polygon angles. So we're going through all of the different operations here with mixed numbers. The next one is to divide, be able to do that accurately. And the key vocabulary here is looking at the inverse, because there's a way that we can do this that makes it a lot easier to divide mixed numbers. If you think about dividing and multiplying, dividing is the inverse operation to multiply. So if we look at the inverse operation from divide to multiply and use the method of flipping the divisor, this means that we've got the reciprocal fraction, so the kind of the opposite of it. Because we are having the inverse operation and we're using the reciprocal fraction, we will end up with the same answer. So dividing 2 1/3 by 3 1/5 is exactly the same as multiplying 7/3 by 55/17. So all I've done there is converted them first to improper fractions to help, and then I have used this second fraction and I've written it as the reciprocal. Once I've got my answer, I can look at then multiplying across the denominator and multiplying across the numerator. So 7 times 5, which would be 35, and then 3 times 17, which would be 51. You can leave your answer like this, or you can simplify if you can. If you are given an answer as an improper fraction, again, you may want to convert it to a mixed number. The second topic, looking at exterior polygon angles. So are you able to, first of all, recall the formula, knowing that all of the exterior angles, so the angles on the outside, all add up to 360. Okay, this is a fact that we need to know. And the formula there to find one exterior angle would be to then divide 360 by n. And n stands for the number of sides in that polygon. That will give us kind of the sum, the total. The total exterior angles will always be 360, and then we can divide it if we have a regular polygon with all equal sides. If our sides are not equal, then we can use some of the existing exterior angles. We know that the total will be 360, so we can find missing angles by subtracting there. So the skills that we need to do with those two topics, we're looking at being able to convert an improper fraction to a mixed number and then being able to divide those mixed numbers. And then when we're working with exterior polygon angles, we need to be able to recall the formula of finding an exterior angle. So this formula here, 360 divided by n. And then we need to use the formula to be able to find an exterior angle in a regular polygon, and then find any angles in an irregular polygon. Another thing that you could use this for is working with interior angles as well. So the interior angle plus the exterior angle will always give us 180 degrees. The final two topics on this next knowledge organiser are ordering fractions and working with ratio with exchange rates. So when we order fractions, you may be asked to put your fractions in ascending or descending order. The word ascending means going up from smallest to largest, and then the word descending will be from largest to smallest. So you can do that by comparing those fractions like for like. The only way you can do that is by making sure all of those fractions are equivalent. So they're put with an equivalent denominator. So you can see here, to order a half, a fifth, and a third, to decide which one of those is the smallest, you would need to make sure that they all have the same denominator first, and then scale those numerators up as well to make those fractions equivalent. Once you've got that information, you can then put your fractions in ascending order. For this question, descending if it's the other question you've been asked, and then you can decide how you are going to order them, and remember to go back to the original fraction. When you're working with exchange rates, the word exchange is to kind of change from one thing to another. And when we're working with currency, so lots of different types of money from different places around the world, we need to make sure that we're using the correct symbol for the currency and changing or converting or exchanging in the correct way. So using exchange rates is a really important skill to have. You can use it in real life when you're going on holiday and you may want to exchange your money into a foreign currency. You would find what your exchange rate is. So for example, from the pound to the euro. So you would convert from pounds to euros by multiplying by 1.39 here. And to go the other way, from euros to pounds, you would then divide by 1.39. You may be given some questions where you've got some money that you need to exchange. You may be given a question where you want to compare the prices of two things, one price in British pounds, one price in euros. So there's lots of different ways that you can apply that skill. So the two things on here, ordering fractions, you need to be able to order fractions in ascending number when all of the denominators are the same, and then also order fractions in ascending order where the denominators are different, and that would apply to descending order as well. And then for ratio and exchange rates, you would need to apply ratios to exchange rates in lots of different contexts. So just to summarize those next 6 topics, can you do the following? Can you solve a linear inequality? Can you complete a table of values? Can you draw a straight line graph accurately? Can you divide mixed numbers? Can you recall the formula for exterior angles and polygons? Can you use the formula accurately and then use that to find interior angles? Can you order fractions either in ascending or descending order, whether denominators are the same or different? And can you apply ratios to exchange rates? So again, if you go on to Corbett Maths, you'll be able to highlight some of these topic areas, have a little practice and see how you get on. Anything that you know you're confident with, you can say you've achieved that, you can do it, and any gaps we can identify and support you with your progress in the future. For the final knowledge organiser for LP2, I've looked at these topics. So error intervals, congruency, compound measure, sequences, so finding the nth term, area of compound shapes, and volume of compound shapes. So again, I'll go through each of those individually, highlight some key terminology, and go over the skills that you need to be able to do. So looking at the first two, error intervals and congruency. So error intervals is the kind of the range of values in which a precise value could be. So you're looking at the upper and the lower bounds of something when it's already been rounded. So you're kind of working backwards with your rounding skills here to identify the error interval. So the width of the bench is this length, corrected to the 1 decimal place. So what we need to find out are the lengths that they could possibly be before this number has been rounded. So we want to think about the smallest possible value that this could be rounded to, and also the largest possible value that this could be rounded to. So you're thinking about the number already rounded, and then you're looking at the smallest possible number and the largest possible number that could be. For congruency, we just want to recap on this again because we looked at this first of all in LP1, being able to identify the conditions of congruency and making two triangles congruent. Remember, the word congruency means that they are exactly the same, however they may have been rotated or translated in some way. And there are 4 conditions here: side, 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 angle, side, angle, side, angle, side, and right angle, hypotenuse, side. These tell us that the triangles are congruent if they have these conditions that are the same. Now this develops on from LP1 because you will need to be able to solve problems with congruent triangles by identifying and then looking at the lengths of sides or missing angles. So the things you need to do with these two topics, with error intervals, you need to be able to find the upper and the lower bounds of different measurements by rounding. And for congruency, you need to be able to solve problems involving congruent triangles. The next 2 topics on this final knowledge organiser for LP2, compound measure and sequences, finding the nth term. So for the key vocabulary here, I've just included the 3 formula that you need to be aware of. So finding mass, density, volume, force, pressure, area, and distance, speed, and time. So you need to be able to work between these 3 different compound measure confidently. If you are given the density and the volume, are you able to find the mass? If you're given the force and the pressure, are you able to rearrange this formula to find the area? And then finally, if you're given the time and the distance, are you able to find the speed? The important thing here with these ones as well is considering your units. So mass, density, and volume. How would you measure those? And what units will you include with your answer? Same for force, pressure, area, and distance, speed, time. Those units are really important. For sequences, being able to find the nth term, we are concentrating on something called an arithmetic sequence here. So you can see that the numbers in this sequence are going up by a constant amount of 3. This tells us that it is arithmetic because the increase of the sequence is a constant amount. It may also be a decrease, that's okay. And we would find the nth term by using the formula for the sequence. So we would first of all find the difference in the sequence, which would be 3. So the start of our sequence would be 3n. Then we would apply the 3n sequence here and then see how I would go from 3n to the actual number in the sequence. So I would subtract 2 each time. The nth term is kind of the formula that's given to a sequence which helps you find any term in that sequence. So whether it was the 100th term, n would be 100. So my number in the sequence would be 3 times 100 and then subtract that 2, so 298. Now you can do that for every single number in the sequence and you'll get the correct number if you found the nth term correctly. So for those two topics, for compound measure, you need to be able to work with mass, density, volume, force, pressure, area, and distance, speed, time. And for the sequences topic, you need to be able to find the next term in a sequence. You need to be able to find the nth term of an arithmetic sequence and also be able to use the nth term accurately as well. And the final two topics for LP2 are area of compound shapes and volume of compound shapes. So I've identified some key vocabulary here. Area, so the space inside the shape, so this kind of green section here. Compound, again, meaning a shape that's made up of one or more shapes. You can see here, the compound shape is made up of a rectangle and a semicircle. And when we work with compound area or any area, we're also using our units squared. So I would find the area of one of the shapes. So this rectangle would be 25 times 20 here. Then I would find the area of the semicircle. So using our pi r squared and divide that by 2 because it's a semicircle. And then the compound area would be adding those two up together. The volume of compound shapes kind of leads on from this because you would use the information from the area of compound shapes and then you could apply that to volume. So the volume again links to the space inside the shape, and then we work with units cubed with volume. So you would find the area of this part and then you would use that to kind of help you find the volume as well. So there's an example of each individual area being found, then the volume, and then finding the compound volume as well. So the skills that we need to master with these two topics, finding the area of compound shapes, and also when you are given the area, can you find any missing lengths as well? And then similarly, when you have the volume of compound shapes, being able to find the volume, and then if you are given the volume, you should be able to find any missing lengths as well. So finally, to summarise the last 6 topics for LP2, error intervals, can you find the upper and lower bounds of a number by rounding? Can you solve problems with congruency? Can you work with the 3 compound measures? Can you identify a sequence, find the next terms in a sequence and find the nth term? Can you find the area of compound shape and any missing lengths if you are already given the area? Can you find the volume of a compound shape? And if you're given the volume, can you find any missing lengths there? So again, go on to Corbett Maths, have a little go at these questions and see how you get on with it. So that's going to give you an overview of everything that you've covered in LP2. Thank you very much. Take care.